Alright, today we're going to talk about logarithms. This is part one of the logarithm series that I'm going to go over. And the whole point of logarithms that you have to understand is that it's used mostly to solve for exponent. Like, think about it. If you have 2 to the x power equals to 4, how do you solve for that x? Because sometimes, it's not a perfect number. Like, you can see that 2 squared is equal to 4, so it's easy to solve for 2 to the x power equal to 4. But what if it's 2 to the x power equals to 5? And that's where logarithms come in to help you solve the problems. And we'll go over some basic concepts. The way I like to present logarithms is to have all the theorems all at one time. I'll just teach you right now the first one, which is log of base b x equals y is the same thing as b to the y power equals to x. And that's all we're talking about in part one, to get you situated. But the thing is, you'll always be using these theorems over and over again. You're either going from here to here or back to here on the other side. And I picked these 7 problems as a good way to understand intro to logarithms. And the first problem we have here says log base 2 32 equals to 5. And the first 2 problems, you're just learning how to rewrite it a different way. So the way I like to remember how to write logarithms in this form is a little, what I like to call a little hook, like a little counterclockwise thing. So I go 2 to the 5th power equals to 32. You see how a little cycle, a counterclockwise cycle? So the way you rewrite it is 2 to the 5th power equals to 32. 2 to the 5th power equals to 32. So see how it's a little counterclockwise thing? And that's how it's done here. So log base b x equals to y, okay, is written the same way as b to the y power equals to x. So b to the y power, you see there's a little hook there, and then you hook back here. It's like a counterclockwise. That's how I like to remember how to do this theorem, okay? So it's the same thing as 2 to the 5th equal to 32, which is correct, right? So over here, it's the same thing. You do the little hook thing. 27 to the 1/3 power equals to 3. So 27 to the 1/3 power equals to 3. And that's correct, because 27 to 1/3 power is the same thing. 1/3 is this cube root of 27, right? Cube root of 27 is 3. So the first 2 problems we're not solving for anything. It's just learning how to rewrite the logarithms into an exponent form, so you can see how logarithms, the structure of a logarithm. And then now 3 to 7, we're solving for actually wait, no, number 4 to 7 we're solving for what do you call that? Actually no, number 3 we're solving for variables, right? I just realized we're solving for b. Okay, so number 3 is log base b, 49 equals to 2. Okay, so we do the counterclockwise thing again. It's just easy to remember this way. And after a while, it'll speed in your head. So that's b squared equals to 49, right? So what can be 49? Well, b, if you take the square root of both sides, you get b is equal to 7 or negative 7. And I'll go over with you, the base can be negative, but later on you'll realize that logarithms cannot be negative. Like this number here cannot be negative. But I'll go over with you later. I don't want to confuse you right now. Cannot be negative. But right now, the base is okay. It can be negative. So the answer is b equals 7 or negative 7. I'm just solving for it, because b squared equals 49. So b, if you do this, you take the square root of both sides, right? And you'll get b equals 7 or negative 7, okay? So next problem is log base b square root of 5 equals to x. So how do you solve that? Same thing, you do the little loop thing. So you go 5 to the x power equals to radical 5. Okay, let me rewrite this so it looks a little more clean. Okay, so how do you do that? Okay, 5 to the x equal to root 5. So what do you do here? Well, you can change the root 5 into a fraction form so you can solve it, right? And square root of 5, since it's a 2 here, it's 1 over 2, is really 5 to the 1/2 power, right? Square root of 5 is just radical 5 is just 5 to 1/2. And you'll see right away x is equal to 1/2. Since the base is equal, you can set the exponents to be equal, so x is equal to 1/2. Let me box these so you see the answers. Okay. See that? Okay. So number 5, we have log base b 36 equals to -2. Okay. So we do the same thing. It's nothing different. There's always just different numbers. As long as you follow the rules, everything's always the same. So we have b to the -2 power equals to 36. Remember? Just a little counterclockwise. B to -2 equals 36. So now, how do I rewrite this? Like, it's a negative exponent. So I can actually change this to a negative exponent too. But what's 36? 36 is a power of 2, right? So it's 6 squared. So let me write this as 6 squared equals to b to -2, right? So now what do I do? How do I make this a negative? Well, to make it a negative, you do the reciprocal, right? So what we can do is just do the reciprocal to 6. The reciprocal of 6 is 1/6, right? You see how I changed 6 squared into -2? So it's 1/6 to -2 now. Because you're doing the reciprocal, so there's a negative exponent. So now that you have the exponents the same, now you can solve for the base. And you'll see the base is 1/6. Okay? So always remember, when you do negative exponents, don't forget that you do the reciprocal, whatever it is. If it's a fraction, you flip it over. If it's not a fraction, you flip it the other way around. Okay, so number 6, we have log base 1/2 x equals to -6. So same thing. We write it 1/2 to the -6 equals to x. And what is 1/2 to the -6 power? Well, one way you can do this is let's change this to a positive exponent. Okay, first. So let's see. Let me rewrite x to the left side. So x equals to 2 to the 6th power, right? Because I do the reciprocal, the exponents, a positive now. You do the opposite of that. And 2 to the 6th power is just 64. Okay? And then the last problem we have, this is, to me, is an interesting problem because you have a radical now in the base, so people can get lost when they see something like, oh no, what's a radical? It's like, I don't know what to do. It's the same rules, right? So you get square root of 3 to the x power equals to 27. Okay? So now you gotta think about, okay, now what do you do here? Well, I can change this into a fraction, right? The fraction exponent. So it's 3 to the 1/3 power to the x power equals to, and let's make this with the same base so it's easier to solve, right? 27 is the same thing as, it's a base of 3 cubed, right? Okay? So what's 1/3 x? Remember the theorems for doing exponents? When you have power to another power, what do? You multiply them, right? So it's really 3 to the 1/3 x equals to 3 cubed. And then what do? Since the base are the same, now you can set the top to be the same. So now it's 1/3 x equals to 3. And then how do you solve that? Well, 1/3 x, you multiply 3 on both sides, right? And that'll be just x equals to 9. And that's how you change the first part of logarithms. All we're working on right now is a log base bx equals to y is the same thing as b to the y equals to x. So that's all we're doing. The next sections, we're going to talk about the properties of multiplying inside the logarithms, dividing, and exponent inside a logarithm. Thank you.